Do you have room in your heart for the five-string banjo? Welcome back to the advent of syntran. Today is day 20. So let's make a new directory and get the input. Getting close to the end here. Only 6 more days left, including today. I'm gonna stop streaming at some point. I have to travel on like Saturday or something, so might only have 3-ish more streams to go, and then I'll at least attempt the last couple days offline, but I probably won't stream those last couple days. Let's check out the input. And we've got a bunch of signals today, if NeoVim will ever open. 58 signals. It's not a huge input. Callie, you can't be up here. I'm sorry. That's your first warning. She's almost certainly going to do that again. So it's not a huge input. What is going on? Did she step on something? Somehow she locked up NeoVim. There we go. No, I guess NeoVim just froze on its own. Yeah, so we have a bunch of signals, or broadcasters. You have some that start with a percent, and some that start with an ampersand. I have to look at the puzzle input. You have 2 different kinds of... I guess I can't call them broadcasters because there's only one broadcaster, but there's one source, and then it can have multiple destinations, and depending on whether it's a percent or an ampersand type, it will do something different with the type of the signal pulse that it receives. So today looks like a doozy. Yesterday was a doozy, and I think we're in for another one. So let's go up to day 20. We've got cables and communication modules. So these things are called modules, and they communicate using pulses. There are 2 kinds of pulses. There's the high pulse and the low pulse. And every line of text in this input has a source and a destination module, or one source and a series of destination modules. So the percents are flip-flops, and the ampersands are conjunction modules, whatever that means. I don't know if this is like a real communication thing or what. This window should stay on top. And then there's one broadcaster, and what happens when we hit the button to start off this whole chain of communication is that the broadcaster sends off... the broadcaster receives a low pulse, and then the broadcaster relays that to whatever its destinations are. Callie, that's warning number 2. She hates it when I stream. Only 6 more days, Callie, and then I'm gonna take a break from streaming for a while. So the broadcaster doesn't have a type. That just basically relays the button input. What does the broadcaster do? Yeah, the broadcaster just relays the low input from the button. And then we have to process these signals in a certain order. Or I should say pulses instead of signals. So like the broadcaster sends inputs to A, B, and C. Now we can't just immediately go to A and start processing that at A. Basically, we're going to have to build a queue of pulses. So we're going to in-queue pulses for A, B, and C, and do all 3 of those. And then, in the order that we have things in the queue, we're going to process the pulse that A has to process, and the pulse that B has to process, and the pulse that C has to process. So like these are all sort of happening in parallel in some sense. Even though my code is going to be single-threaded, there's not really any parallel versus serial distinction. But if you have like a queue versus a stack, you have to be careful about the order that you process pulses. So some of these modules have an internal state, like the flip-flop can be on or off, and the conjunction like remembers its previous pulses, and then it does different things depending on that internal state. And they want to know how many pulses are sent. So we're going to push the button 1,000 times, and then we want to know how many pulses get sent in total between any source and any other destination. And sometimes one button press will get you back into the same state that you started in, with the flip-flops being on or off and the conjunctions remembering their signals. So the same thing will happen every time you press the button for some examples, but there are other communication networks where pressing the button once will change the state after everything is done. So then the second time you press the button, something different happens relative to the first button press. Okay, so we need low pulses and high pulses, and then multiply those together. But we're going to have a lot of work to do before we can multiply anything, or before we have any numbers to multiply. Because today is definitely a doozy. It looks about as bad as yesterday, and that took me like an hour and a half for part 1, and then I worked on it afterwards for about another hour, and I eventually got part 2. But it wasn't super hard, but it was pretty time consuming. Okay, so this is the test input. Or this is one of the test inputs. I think they have a few. Like this one has an inverter here and another conjunction module. So they give us multiple examples. So I should be able to echo that. And there's the input echoed. Okay, and we're going to get started sort of similar to what we did yesterday. We have to parse a lot of input to start out. We have to know where the broadcaster is, and we're going to have a table of labels, module labels or module names or module identifiers. So there's going to be broadcaster and A. We only care about what's on the left of this arrow symbol for all the function labels. So that, and then A, then B, then C, and finally the inverter. So I want to put those in an array and then look everything up by index. Callie, this is your final warning. I don't know why I count down 3 or 4 warnings for Callie. It's not like she understands that I'm gonna close the office door after the 4th time she jumps on the desk. Yeah, so I want to build a table of module names. I need to have a queue for the pulses, so I need to set up like a global variable to hold that data structure. I don't have structs in my language, so having global variables is the best way to do things. For now, at least. And eventually I'm going to need to parse the types of every module, and then I'll need a list of the destinations of every source module. So this one has 3 destinations, everything else only has 1. For this example, here there's something else that has multiple destinations. Oh man, this is probably going to take a while. And I have no idea what's coming in part 2, so that's probably also going to take a while. I hope it's not like exactly the same as yesterday where they just ask us to work backwards through the network or something like that. Because I'm a little bit tired of that. Even if it isn't, though, it's probably going to be something else that's equally difficult as yesterday. I think I just want to count lines to start. And modules. I'm going to say MOD for modules. I think that's what these things are called. I don't know why my window manager keeps wanting to switch back to OBS. So these things are called modules. We've got high pulses and low pulses, so I want to set up things to keep track of all of that stuff. So a low pulse, I'm going to call that a 1, and a high pulse is going to be a 2. Maybe I should use 0 and 1. I don't know. It doesn't matter. These are basically an enum, so it doesn't really matter what the values are, as long as I don't have these magic numbers duplicated in a bunch of different places in my code. I want a Q. I don't really know what's going to be in that yet. Because for every pulse, do I need to keep track of the destination? Yeah, I think I need to know the destination, but I don't necessarily need to know. I need the destination and the type of pulse. So I think this is going to be like a 2 by something array. I don't know how big this needs to be. We'll start out with that, and we'll make it bigger as we need to. So this will hold the pulse type and destination for all of the pulse signals in the queue. And then we're going to need like the queue beginning and the queue end. And I need a queue because I need to process these in order, and whatever pulse gets sent first, I need to process that first. So this is a first in, first out data structure. That's a queue. A stack would be the wrong thing for this problem, as long as I understand the input correctly. So do I know how many modules there are? So I need any num for pulse types, and I think I also need any num for the module types. So we've got flip-flops and we've got conjunctions. Maybe we also have a broadcaster. And that's like a special case because there's only one broadcaster. Okay, so we have 5 modules. Let me open this up in a different pane. Okay, so we do have 5 modules here. So we have broadcasters. I think percent is a flip-flop, right? What window does this keep switching to? Is it because the chat is on top? My window manager is not... The built-in window Microsoft Windows window manager is not behaving for me today. I expect to hit Alt-Tab once and switch to my previous window, but it's not doing that. I have to hit 2 things. Okay, you're out of here, Callie. I'm sorry. Did I get these module types correct? Do they call them types? Oh, there's an untyped output module, which they only have in the second example. Do we have an output over here? What? Well, that's weird. Window manager, come on, behave. Okay, Chrome, Ubuntu. Chrome, Ubuntu. No, I don't care about outputs. I'm looking for output. So it's just an untyped module for testing purposes? What the hell is the deal with this? It's not even in the actual input. So output only exists on the right-hand side. It's never on the left side. So this is really a special case. Anyway, I think I was looking for the types. Okay, flip-flops are a percent. So I think I also need a state. So flip-flops are a percent. And conjunctions or conjunctors, what the hell are these called? Conjugators, they're conjunction modules. They have an ampersand and they remember the type of the most recent pulse received from each of their connected input modules. So inv is a conjunction here and it has 1 input. It only takes a pulse from C as input. And then you have an inverter here that takes an input from A. Well, I don't know why I called it inverter. Did they use this word? Yeah, it acts like an inverter. It sends the opposite of the pulse type it receives because it only has 1 input. Okay. So that only has 1 input, but con here, this one has 2 inputs. So it has an input from A and it has an input from B. So like yesterday, I need to have a table of module names or module labels, and then I'm also going to need to invert that table, or I'm going to have a table of outputs of each module, and then I need to invert the outputs table to get the inputs of each module. So that's also very similar to something that we did yesterday, which is, I feel slightly annoyed that I'm having to do the same thing 2 days in a row. flip-flops are on or off, and they're initially off. So each module type has a different kind of state. So flip-flop has like one state variable. It has essentially a boolean that's on or off. Yeah. I only have like 58 lines in the real input, so I think I want to waste a little bit of memory and have a Boolean state for every module, even though only the flip-flop modules will use a Boolean state. Because if it's on or off and it gets toggled, it would be very nice to just use a Boolean type for that. You could use integers and do something like modulo 2, but I think a Boolean is the right type for the flip-flop module state. And then the conjunction, it has a more complicated state. So it remembers the type of the most recent pulse from each input. So every conjunction module could have multiple inputs, so it's going to have a state variable for every one of its inputs. And that could either be a low pulse or a high pulse. So I want some more global variables for that stuff. This is going to be a Boolean, and these are initially off, so, right? Flip-flop modules are initially off, so I'm going to say off is false and on is true. I think that makes sense. I don't need to encode that as constants, but maybe I should at least put a comment. And this, we don't know the size yet. I'm going to allocate this for later, but for now I just want to declare it as a global variable. I mean, this is a convention that I'm using, so I think it's worth making this comment. You could use another convention if you were insane, but I think this is really the only logical way to do this. You could use integers, like I said, but I think Boolean is correct for this. And maybe these don't need to be global variables, but just it's easier to start them out here and then move them later if I want to. So this is going to have two sizes. And it's going to be numeric. What are the conjunction? What are the conjunction modules initially? They initially default to remembering a low pulse. So I haven't actually allocated it yet, so this doesn't really matter, but I'm going to put low. And then this is going to be a rank 2 array. Because the flip state is like a scalar. Every flip-flop module only has one state variable, but this needs to be an array because there are multiple flip-flop modules. This one needs to be a rank 2 array because there are multiple modules and every module has multiple state variables. Broadcaster. Yeah, it's broadcaster, not broadcast. I'm tired already. And I haven't even started, really. I read the lines as strings, and this was already in my template, and then I haven't done anything with these yet. So now that I know nmod, Is that enough to allocate my state variables? No, because for the conjunction state, I also need to know how many inputs every module has. This can be a for loop. So I want to split by this. I want to split by this, and then the inputs will be on the left and the outputs will be on the right. And then later I can split the outputs by commas and spaces, technically. Yeah, do I want to split by spaces already? Yeah, I think I want to get rid of the spaces. So split by dash greater than spaces and commas. Dash greater than spaces and commas. Dash greater than spaces, commas. I think that was everything. I think so. So then the left-hand side, or the first element of that split vector, is going to be potentially a type. There could be a percent or an ampersand, and then the source label. So then what do I want to do with that? Like if it's broadcaster, this is special because it's untyped. It's called LHS for the left-hand side of the arrow operator. Strings 0. Okay, so we have broadcaster, and then %A, %B, %C, and ampersand inv. Yeah, so then I want a little switch case to check if there's a type, like a % or an ampersand for a flip-flop or a conjunction module. So if LHS 0 equals ampersand or %, then we're going to do one thing. If there's an ampersand, if I can type that, then we're going to do something else. And finally, we have an untyped module. I think the broadcaster is the only one that's untyped, except for the output in the other example, but none of the other examples have an untyped output module. Maybe I want to... No. I guess I want two different cases. Do I want to handle like the other untyped case because it doesn't actually show up in the real input? Yeah. Yeah, the thing is, if we have an untyped output module, it never shows up on the LHS. So I can only have these three types. So now that I know nmod, I can allocate some of these things. I also need to know the types. Types, yeah. What was your thing? Flip state is singular. So if I make that singular, I should make the types singular. Yeah, I don't know. I'm not consistent. Do as I say, not as I do. Don't know the size yet. But after I read the number of lines, or count the number of lines, then I can allocate all of this stuff. So type is going to be 0, or it's just going to be nmod, size nmod. Then the flip state is going to be false by nmod. Not every module is a flip-flop module, but I'm wasting a little bit of memory here. And just having a state variable for every module, even the ones that aren't flip-flop types. I cannot allocate this yet because I don't know how many inputs every module has yet. I could just give it some hard-coded upper capacity. I think I might do that because I don't want to make multiple passes over this input unless I really need to. Conj state. I don't think I really need to allocate these yet. I can do this later because I'm gonna have to make a second pass over like the internal representation anyway to like map the inputs and outputs or sources and destinations for everything. And this size is going to be max inputs by nmod. And we'll have to figure out what max inputs is at some point. Okay, so all I really needed was the type, because that's what I want to set in here. So type I equals flip. Right, percent is flip. Flip-flops have a percent prefix, and then conjunction modules have an ampersand. And there should only be one of these, but let's do that anyway. Now, for these two cases, the name of the module is going to be everything after the first character. For this case, it's just going to be the whole LHS string. So I need an array of labels. Named broadcaster. So they call these names. I'm going to call my variable name in that case. These do not all need to be global variables, but I started off like this, so I'm going to continue down this path. So in this case, it's everything after the first character. -1? No, no -1, because this isn't inclusive of the upper bound anyway. And for the broadcaster, it's just the whole string. Or I could just hard code this to broadcaster. So let's check some of those. I'm not ready for that because I don't know what the max inputs are yet. I think I did not allocate the names. There we go. So we have a broadcaster, that's type 3. Let me open that up over here. We have a broadcaster, that's type 3. Then we have 3 flip-flops, so 1, 1, 1. And then finally we have a conjunction module, so that's an ampersand. And then the names, those are the names. Now I think I want to handle the right-hand side. So I want to split that again. And I want to split that by, well, no, it's, I don't need to split again because I already split by every possible delimiter. So I need the max inputs and I also need the max outputs. Yeah, I really don't want to make multiple passes, so I think I'm just going to have some hard-coded upper bounds. But I need the whole name table before I can do any more processing, so I'm going to have to make a second pass anyway. Maybe it was a mistake to split like this. Because if I don't split by space, I'm going to have an extra space at the end of every module name. So I'm going to have like broadcaster space, and then A space, and then B space. This is annoying. This is just so much parsing work before I even really get to the problem. Or before I get to solving the problem. So I don't want to split by that stuff yet. And then I want to split again to get rid of the trailing space. But before that, I want to save the RHS. So that will remove the spaces. No, because now it's not a scalar. This is so annoying. I'm tired of Advent code. we're just going to save that for now, and then we're going to make another pass to really process that. And then I need to allocate the RHS. What did I do now? Probably one of these strings isn't correct. Did this print anything before it crashed? We got the first line. I shouldn't have to debug this. I should have just gotten this right on the first attempt. I've already been at this for 40 minutes. This is not fun anymore. Okay, so we got that, and yeah, there's an extra space at the end of broadcaster. So that's why I need the second split to remove the space. Then I guess we crashed here. Okay, we got the RHS. Does this not work when I have a variable on the right-hand side and the same variable on the left-hand side? It should in any reasonable language, but I'm not so sure about syntran. This is embarrassing that I have to do this level of printf debugging just to parse the input. Yeah, so it's not splitting this. Strings 0 is broadcaster. Fine. We'll try like a temporary variable. This should not be necessary. Okay, there we go. That was annoying. But that should have worked. Because everything is passed by value. So if I was passing by reference, it might make sense that this would crash. But when I pass by value, this part of the array should get copied to some argument or parameter of this function, and then everything should just work. Hey, Nan, thanks for the raid. Hey, Justice, or I think I'm pronouncing your name wrong now that I know you're German. I think it's probably Justus or Eustace or something like that. I can carry the torch, thanks. This is a really hard one today, and I'm tired from day 19, and then day 20 is just as hard as day 19. I think I should give a brief explanation for everybody who just joined the stream. So We're working with a network of communication modules. So like there's a broadcaster module, and it sends a signal to modules A, B, and C. And then A sends a signal to B, B sends a signal to C, C sends a signal to INV, and INV sends a signal back to A. So there can be loops in here. There are percents for flip-flop modules, and there are ampersands for conjunction modules, and all of these modules behave in different ways, and they have internal states, and they send different kinds of signals. Day 3 for 3 days. I mean, day three was a little bit tricky. Like days 1 and 2 were okay. Actually, even day 1 this year was not totally trivial. Is this Baby Shark? Why is this freezing? I think I need a new PC too. I usually stream without music, but I'll make an exception. I'll probably get like a copyright strike when I try to upload this to YouTube. Sorry if there's an echo. I work without headphones, so you can probably hear a terrible echo. We have the types, I have the names of every broadcaster. Now I think I was working on parsing the right-hand side, but I want to do that later, actually. This isn't Baby Shark? Are you sure? Yeah, I think everybody watching right now is from the rating. I think some people recognize the YouTube link, even though it's just like random letters. I think some people recognize the Rickroll link. I didn't do that, but just in the context, like I've been trolling Nan all day, so I feel like I deserved that. Nan doesn't know what Rickrolling is? Well, now she knows. Yeah, sorry, I'm not going to let the audio play because I think there's probably an echo and it doesn't sound that good. Yeah, so now I have to process the right-hand sides. Didn't even know it. Okay, so the first line has this as the right-hand side, and then B. This looks reasonable. Oh, my editor. Yeah, it's NeoVim. Oh yeah, it's 1:30 in Deutschland. It's pretty late. Have a good night, Justus. Wait, sorry, I missed the editor comment. Yeah, this is NeoVim. This is also NeoVim. So I have it aliased so that I run it as VI, but it's really NVIM. And this is NeoVim with the Tokyo Night theme. I have to look at my config to remember. I don't remember where it is. Yeah, it's Tokyo Moon. The problem with the NeoVim config is I don't just have one Vim script file. I have like a whole tree or a whole GitHub repository of NeoVim dot files. So I never know where anything is defined. But yeah, the color scheme is Tokyo Moon. And this is NeoVim. So what am I doing with these right-hand sides? It is Lua, yeah. I'm saying like I used to use VimScript, but now I'm converting to Lua, so I have these -- comments, and now it's vim.cmd.color scheme. Like we have this whole .NET mess of namespaces where everything is like 3 namespaces deep to do anything useful. Yeah, it's kind of a pain to configure. I spent at least 2 weekends just configuring this. But it's fun. Before this, I was using Vim, and then I just switched to NeoVim, so it really wasn't like a huge change for me. Helix, yeah, I should try Helix. No need to configure much. I mean, you don't need to configure it if you like the way it works by default. But I have things that I'm used to, like I like to hit the tab key to autocomplete. So that's something that I have to configure, because by default it's like some weird 2 or 3 key keyboard shortcut. Okay, so I want to split this right-hand side by commas and spaces. And these are going to be like the outputs. The Helix defaults are pretty decent. Yeah, there are things that you can do like that for NeoVim. I forget the names of them, but you can just like download one plugin and then you have like somebody else's idea of good defaults, and then you don't have to mess with a whole bunch of other comments and a tree of config files. So I want to split that by commas and spaces. Okay, so now instead of A, B, and C, I have a vector of A and then B and then C. Kind of feel they tend to make my editor sluggish. Yeah, I don't know if you were here for it, but like I opened up the input and it was pretty fast that time, but sometimes it takes like a second or 2 for Vim to really start up. So I think my PC is just not that fast, but it's not as instantaneous as I would like it to be. That's why you switched from VS Code, because VS Code is slow. All right, yeah, have a good night. It's it's really late. Okay, now what do I want to do with these outputs? I want to look them up in the table of module names. So I have to iterate through every output in the outputs. Why do I have an extra space here? Size outputs 0. That's not what I wanted to do. Okay, so here we have 3 different outputs. And now I want to look these up so that I can have an integer array index instead of a string. I think I already have a variable for this. So it's called elt. And I don't know the size yet. So how big does this array have to be? I think I have to do a little bit of processing here just to count the outputs. And now I should know this number. I think it should be 3 for the test input. Okay, so that's 3. Like this one has 3 outputs and everything else only has 1. I just deleted something. Everything else only has 1 output. So that makes sense. And now that I know this, I can allocate the array. So it's called elt, and the size is max elt by the number of modules. So this is j comma I. Yeah, so while that does not match what we're looking up, we want to increment it. Whoa, what did I just do? not equal out str. I think that's it. Okay, so the broadcaster outputs to index 1, which is A. So indexing from 0, this is 0, then 1, then 2. So the broadcaster outputs to 1, 2, and 3, A, B, and C. And then A outputs to 2, which is 2. And then B outputs to 3. So I think this is what I wanted to look up. And then what? Then I think I have to invert this table to get the inputs of every module. And like I said, this is exactly what I did yesterday. It's like the same problem over again. I think I also want the number of outputs and the number of inputs for each module. So I need variables for that. These really don't need to be global variables. In fact, I'm making more work for myself by declaring them up here and then allocating them somewhere else. Instead, I could just allocate and declare at the same time. So we know the number of modules already. We could get it right here. So I think we can also count during this loop. Before I do that, I just want to see if this will run right now. No, it crashes. It crashed really fast. Why did that crash already? I have way too many global variables. This was a mistake. Does it even count the lines? It doesn't even count the lines. It just crashes immediately. I've done something terrible. Did I like delete the input? I don't think so. What is going on? So I declared these, and then it crashed. It doesn't even print this. So... I think it's crashing while allocating one of these global variables. Maybe having arrays of size 0 is bad? I don't even know what's happening. Advent, what day is this? This is day 20. Welcome to the stream, Bad Cup. Yeah, this one is rough. Oh, spoilers, yeah, you gotta go. I'm still working on parsing the input, so, well, I've read the input into strings, and now I'm processing the strings into an internal representation, so you probably won't see any spoilers yet. I don't know why everything is crashing. Yeah, day 19... I thought day 19 was fun, and then this feels like the exact same thing as day 19 again. So I'm a little bit annoyed. Lots of repeats. Yeah, it's like a lot of parsing and then looking up tables of names. I guess if I had hash maps in my language... Bash has hash maps, so that might make this easier for you, but I don't have hash maps built in. 18 was like day 10. Oh yeah, but you have to use a different approach, I think. Like, you can't do the flood filling. Am I doing this in Fortran? Not exactly. I'm doing this in syntran. This is my own language, and the interpreter for syntran is written in Fortran. So there is Fortran at some level. Oh yeah, you have associative arrays. Is there a difference? Welcome to the stream, Big Chris. I don't know what happened. Everything was going pretty smoothly. And then I made some changes, and now my program crashes immediately. Like it usually prints something. This is coming from the interpreter, so this is not my print, but then it should print something. It just crashes immediately. I don't know what I changed. I think I just have to comment out like all of the code that I just wrote. Oh, why does this compile? I was like, I'm going to fill in this for loop later, so I'm just going to put ... for the iteration. How does... That's definitely it. Okay, that's a to-do note for myself as a syntran developer. Why does that just crash the interpreter? Yeah, that was definitely it. This is why I tell people, do not use this language. You will run into things like this. So what should this loop be? I just want to iterate through the modules. Okay. Man, that's really weird. That should not crash the interpreter. Okay, so I have module names, and there are these right-hand sides. So I've looked up the outputs, but now I need to invert this output table to get an input table. And before that, I should be able to count the inputs of everything. So the number of inputs is initialized to 0. And then that's not what I need to do. Every time we have an output, an input should also get incremented, or a number of inputs should also get incremented. Which one should it be? I think that's it. So what do I expect? A has 2 inputs because A takes input from the broadcaster and from the inverter. I think everything has 2 inputs except the inverter. The inverter only has 1 input. So I'm expecting a bunch of 2s and then a 1. Yeah, so a bunch of 2s and then a 1, and then I forgot about the broadcaster because the broadcaster only has outputs, it doesn't have any inputs. So that looks correct. And now I also want to know the max inputs. So we already have max outputs. But I also need to know max inputs. Is that initialized to 0? Yeah. By the way, I want to point out that Fortran does not have compound assignment. You cannot do plus equals in Fortran. So the way that you would have to do this line in Fortran is like this. What am I typing? This is basically what you have to do in Fortran, except you use parentheses instead of square brackets, which is also kind of weird, but it's a language from 70 years ago, so we have the syntax that we have. But like, why can't it have compound assignment? It's really annoying to put this on the left-hand side of the equals sign and to have it copied on the right-hand side of the equals sign too. Because like, if you just have a scalar variable and you're doing like x equals x plus 1, that's okay. I don't care about typing x 2 times, but if I have to type all of this 2 times, that's super annoying, and it's super error prone when you have like nested array indices and arrays with multiple indices. So Fortran needs to have this. I don't know why they don't have it yet. It seems like something that should be relatively simple to add to a language. So did I get the max inputs? Okay, max inputs is 2, so that makes sense. Before I continue parsing this input into an internal representation, I need to grab a drink, so I'll be right back. Also, I have to feed my cat, so it's going to be a minute. All right, we're back. So I know how many inputs there are. Now I can allocate my input table and then invert the output table. This is going to be max inputs by the number of modules. Okay. And I actually... I only did this so I could get the max. I actually need to reset this to 0 now. Kelly, we already had this discussion. I want to reset that to 0. And then I sort of want to repeat this loop, but without the string processing. So the input at this expression, comma, remember this table is max input by n module, so the first input is going to be one of these numbers, or the first index, and then the second index is just going to be the module, so I equals that. I think that's how I invert this table. So let's see what that is. Okay. So this doesn't seem right. Because the broadcaster has no inputs. So why does it say 3? Oh, I got these backwards. I think. That's better. So the broadcaster has no inputs. So it has no inputs, and if there were any values there, there aren't any. They're just all zeros. Now A takes inputs from the broadcaster and the inverter. So from 0 and 4. So A's inputs are 0 and 4, B's inputs are 0 and 1, C's inputs are 0 and 2, and the inverter's inputs, well, there's only one of those. The inverter's input is 3, which is C. Yeah, that looks correct. Okay. I think maybe we've parsed everything. I think I might be done with parsing after an hour and 23 minutes. Man, that's rough. It wasn't just parsing though, it was also like constructing an internal representation of, I guess, the program that this input represents, if you want to think of it as a program. Okay, now how do these pulses work? Dot. I'm still thinking about how did this crash the interpreter. Dot. Oh, it might be trying to parse a float. Because floats are weird. Like you could have 1.234 times 10 to the 5. That's a floating point number. So there can be a dot in a float. So if it sees a dot, it might think that this is a float, because you could have like a float that's just 0.234. So it sees this, it probably thinks it's a float, and then it tries to parse this expression as a float. But when it reads this as a float, it can't do it, and the Fortran float reading function just crashes, and I don't handle that error, apparently. So I think that might be what's happening. Because like these two lines, I think they should be valid. No, that's an unexpected character. So yeah, you have to have a leading 0, don't you? Okay, maybe not. I don't know what's going on there. Anyway, that's beside the point of advent of code. I want to squeeze my J's and I's together. I think it's a little bit more readable that way. Maybe. That's a value judgment. What I should do is have a temporary variable that's just that. Yeah, I think that would make this a lot more readable. And then we should get the same table again. I want to take a screenshot of that so I can remember what I'm expecting right there. That's a generously large screenshot. Okay. I think that's the same as what it just was. That's good. Run it one more time just to be sure. Because like sometimes I don't save in my text editor, and then I'm not running what I think I ran. Okay, so now I can actually allocate the state, because I know the max number of inputs. Okay, and then now I'm gonna try to do one button press, and then what they're asking for is for me to do like 1,000 button presses. This is just so much. I hope we get like at least one easy day in the next 5 days or something. They can't all be this hard. I don't feel like I've even done anything difficult yet. I've just done so much parsing work and table lookups and table inversions. I think I have to look at the prompt again because I don't even know what I'm doing. So what are we doing with pulses? There's so many occurrences of the word pulse. This is ridiculous. Okay, so the broadcaster sends a low pulse, and it always sends a low pulse to the broadcaster. So the button is kind of useless. All it does is trigger the broadcaster, but this is going to be the first thing that we push onto the queue. So I think I need queue pushing and popping functions. And what are we going to push? Do we need to know the source? I think we don't need to know the source. We just need to know the pulse type and the destination. So we're going to send a low pulse to the broadcaster, and that's what we're pushing onto the pulse queue. So I already have this queue declared, so it's 2 by queue cap. So the 2 is because we have the pulse type and the destination. But I don't think we need to know the source. So it takes the pulse type and the destination. And it returns nothing. It just modifies the queue global variables. Are push and pop the right names for a queue? Maybe I should call these NQ and DQ. I don't know. I like push and pop, but I don't know if those are supposed to only apply to stacks. So the pulse Q, 0 Q end equals the pulse type. And then the other thing is the destination. And then we increment the Q end. That should be it for pushing. And then I also need a pop function. That does not take any arguments, but it returns a vector of integers. There are going to be 2 things in this vector. There's going to be the pulse type and the destination. So we're gonna pop these from the beginning of the queue because this is a queue, it's not a stack. So it's going to be the pulse queue 0 at the queue beginning and 1. And then we're going to increment the queue beginning. I think that's it. Does this parse? did something wrong. Pulse type. I need function. These are functions. I forget how my own language works. But that's okay, that's why I have parse time error messages. Okay. That parses. Now, we get to start processing these pulses. So first we push the button pulse onto the queue. So we're going to call push, and how does this work again? It takes the type and then the destination. So the type, I think it's a low pulse, and then the destination is the broadcaster. I think I need to look this up. I have to look this up in the table. I think I have to declare this. And it's going to be just like this lookup. So while name broadcaster does not equals, by the way, I have a string not equals operator now. So if you want to run this, you will need version .33. I have this in the README. Yeah, so you now need syntran version 0.0.33 to run this code, because before that I did not have the not equals operator for strings. So previously I had to do this like this. I had to put the not out here, and then I had to use parentheses, because without parentheses the not would bind directly to this, but you can't negate a string. You have to negate a boolean. And this was really annoying, and I mentioned yesterday that like I should really just add this to syntran, because it's going to take me like 5 minutes to add, and it's very useful to have. So that should just be 0, actually, because it happens to be the first line for the test input. But I don't think that's necessarily always the case. So if you look at the real input, the broadcaster is all the way down at line 26 or index 25. Okay, so we fire this off by pressing the button. And then we're going to loop until the queue is empty. I think that's how this works. So what the hell does a flip-flop do? Okay, if it receives a high pulse, it's ignored and nothing happens. So in this test input, you press the button once. The last thing that happens is the inverter sends a high pulse to A, but A is a flip-flop, so it does nothing when it receives a high pulse. So after this signal, nothing else happens. So basically we press the button and then a whole chain reaction of pulse signals gets fired off, and eventually it should settle down and stuff should stop happening. And we just want to loop until the queue of pulse signals is empty. This part might not be that bad. Just parsing and constructing the internal representation has taken me like an hour and a half or whatever. But this part might not be that bad. So you just want to loop until all of the pulses have been handled. So that is while Q beginning is less than Q end. And then we're going to pop something. So we're really popping a signal, and a signal is a pulse of a certain type to a certain destination. So let signal equals pop. And then signal is a vector. It has a pulse type and a destination, so we have to unpack those things from a vector. And this is just according to the convention that we have up here, where the type is at index 0 and the destination is at index 1. So these indices are just according to convention. So this should push one thing, and then one thing should get popped, and then I haven't done anything, so this loop should exit. Why do I have an extra space here? There we go. That didn't work. Bad type expected array. Does push... Who expected an array? Why? What? That error message needs to be better. Oh, this has to return a vector. And this is how I do returns for now, because I don't have an explicit return statement. And there's no type checking to check that a function returns the right type, so that ends up being a runtime error instead of a parse time error, as it should be. That's something for me to work on as a syntran developer. Okay, so we pop off low and destination 0, so that's it for now. Now we need to process this. And that's just going to depend on the type. So we had the switch of this thing. So we either have a flip-flop or a conjunction module or a broadcaster. So I want to copy this and then refactor it a little bit. So if pulse type equals flip, we're going to do something. Or if the pulse type equals conjunction, we're going to do... this is not the pulse type, this is... Yeah, this is not what I want to do. I think I will need this later, though. Yeah, this is not what I want to do. So a pulse is going to a certain destination. Okay, yeah, I think I had this right, but this left-hand side of the equals equals is not right. So if the type of the destination is that, I need an underscore there. Okay, so Now I have to look at the puzzle input and remember how the hell a flip-flop works. So flip-flops are either on or off. So if we get a high pulse, nothing happens. We'll do it like that. There are only two options for pulse types, so maybe I should use a Boolean for pulse types instead of integer enums. If it gets a low pulse, it flips between on and off. If it was off, it turns on. If it was on, it turns off, and then it will send some type of pulse. So at the end, we're going to toggle the state. And where do I have that state? It's called the flip state. So the flip state of the destination is going to get negated. And that's after we do something with this. So before that, we have to check this condition. Then else something else. So if it was on, it sends a low pulse. We know it turns off, we handle that down here, but inside this block, all we have to do is send a low pulse. It sends a low pulse. And what's the other case? If it was off, it sends a high pulse. I have these backwards. If it was off, now I didn't edit this, so I'm getting confused. If it was off, it sends a high pulse, right? If it was off, it sends a high pulse. And then it's going to send that to every one of its destination modules. So for messing up the keyboard shortcuts, I am tired. This is like a long problem, and I just solved a long problem yesterday. So A gets something. It only has one output, but always only have one output. I don't think that's true in general. Like the inverter, everything here only has one output except the broadcaster, so this is a bad example. Here we have a flip-flop, right? Percent is a flip-flop with two outputs, and here there's another one. So it will send that to every one of its outputs, I think. Do they have another example here? Here's a more interesting example. Yeah, so A has two outputs. So A, it sends a pulse to inv and it sends a pulse to conv or con. So when a flip-flop gets a pulse, it sends something to every one of its output modules. So we set this to pulse, and now we have to send this to every one of the destination modules. So it's going to be like the output of the destination, because right now we're handling some other pulse, and we're going to push this onto a queue now. So for J, I think I have to use J now. Oh no, I'm not even using I. No, I think I want to use J anyway, because I typically use J for like an inner loop through, not through the modules. I is typically iterating through all of the modules in all of the parsing work that I've done so far. So the number of outputs of the current module, which is DST, we're just going to push. So we're going to push the pulse type and then the destination. So the pulse type is just the pulse variable. And then the destination is going to be the output J of module DST. I think that's it for flip-flops. What will this do? Probably something. So pulse type low. Oh, I haven't handled the broadcaster yet. So we pushed something onto the broadcaster, but then the broadcaster doesn't send anything to anything else because we haven't written code for that yet. So the conjunction module is to do, because that one's a little bit more complicated, if I remember correctly, but the broadcaster shouldn't be too complicated. And what does it do? I think it just relays everything from its input to its output without checking any internal state and without changing low pulses to high pulses or vice versa. So what the hell does a broadcaster do? When it receives a pulse, it sends the same pulse to all of its destination modules. You just have to read the puzzle prompt so much for this one. It's like reading documentation. I have to be like, okay, what does a broadcaster do? How does it work? How does everything like follow rules according to its internal state? This is just... This puzzle is just tedium. There's nothing interesting here so far that we haven't already done yesterday. It's just more tedium. And of course I want to have like all my comments nicely line wrapped to like a reasonable width right margin. Okay, so it's going to be like this. But pulse is it's just the same as pulse type. So we're just pushing pulse type, and I think that's it. So this should do something now. Okay, yeah, we pushed a few things, but we're not handling the conjunctions yet. Is it worth comparing this with the description? So button goes to broadcaster. I think that's this line. Then broadcaster goes low to A, low to B, and low to C. So those are those three lines, 1, 1, 1, 2, and 1, 3. And then A sends high to B, B sends high to C, and C sends high to inverter. So I think this is actually all correct. And then we stop because we can't handle the inverter, because the inverter is a conjunction module. It's not a flip-flop module, and we just haven't implemented that yet. So what the hell does a conjunction module do? So the flip-flop, it depends on what its state was, and then it sends a pulse. They say it turns off and then sends a pulse, but really the type of pulse that it sends depends on the state that it was before we send the pulse. So for the flip-flop, we pushed a pulse and then we toggled the state. I've got a lot going on. I cannot remember Windows keyboard shortcuts. The conjunction, it first updates its state and then it sends a pulse. Or it does nothing in some cases, I guess. No, it always sends something. Oh, for that input. Okay, I need to modify my queue because my queue does need to have the inputs, because the conjunction state will depend on which input it came from. So first of all, 2 should have been parameterized. It should be like end state. I don't know. I don't know what to name it, so I'm just going to name it 3 now. Let me search for 2 as whole words. Okay, those are the only occurrences. Yeah, so there's no point parameterizing this because this is the only place it occurs. I'm going to have destination before the source because I'm not going to change this number. I'm just going to append it to the end. So 2 is going to be source. This is a terrible, like, what is this, Intel assembly order? It really makes more sense for me to have the source before the destination, but I'm just modifying this and appending it to the end of the arguments that I already had, so I'm going to do it this way. This is so annoying. So this thing actually doesn't really have a source, so I'm just going to do that as -1. It doesn't matter because the broadcaster doesn't care what the source was, it just relays the same pulse type to all of its outputs. These things are so annoying. How does the state work? How does the conj whatever module, how does this thing work? It's like, what do I want to pass as the source? You know what? We only have 58 modules. I was thinking... How many does this have? It's behind the chat. We'll never know. So this one has 5. No, but look, what matters is how many inputs it has. I'm just going to make a huge table. So for this input, which has 58 modules, the state is going to be 58 by 58. If you want to save memory, you could make it max input, and then you have to map the destination to like which input of each conjunction module is it. But I'm not going to do that. I'm just going to make this array huge. It's going to be nmod by nmod. And then when I get a state that says this came from a certain source, I'm just going to update this index, and I don't have to do any index mapping. Because like every conj would have to have a different index mapping, and that's a little bit annoying, and I really don't feel like doing it right now. So we're just going to make this array big and not worry about memory because it's only 58 by 58. This is not something that needs to be optimized. I better be able to wrap up part 1 soon. This has been 2 hours. This is like as long as I want to stream on a Wednesday night. So, how the hell does a conj work? Let's go back to the documentation. So did I initialize this right? So it defaults to a low pulse memory. So it defaults to a low pulse memory. Let's just copy all of that. I have to unpack. Wrong argument count. Yeah, I have to push correctly. So when I push, I also have to push it's coming from DST. So it's confusing that DST is now the source argument, but this pulse that we're pushing is coming from DST. And the same there. Okay. So that still parses. Now we still have to handle the conj. And I'm not even going to bother trying to remember what conj is short for because I don't care. I have had it with today. This puzzle is way too long. And it's just tedious. It's not even an interesting problem. Maybe part 2 is going to be interesting, but I don't think I'm going to have time to do that on stream. So, we have to update the conj state. So conj state. Do I do dest source or source dest? I think it doesn't matter as long as I'm consistent. But I want to have the innermost index be to the left for efficient striding. So I want this to be source dest. equals pulse type. So what did I, yeah, it's just pulse type. For all inputs. This is only for the inputs that it has. So I made this huge array, but now I actually do need to do the mapping. The number of inputs for dest. So first of all, I just want to print j. I'm so tired. That's an infinite loop. Okay, so the inverter has one input, so we only print j once. Or yeah, the inverter has C as an input. Now I have to look up C in some table. So if it's C, that should be 3. This is at line 4, which is index 0. Or line 4, which is index 3. So I'm expecting a 3. All right, we got a 3. Okay, now that's the thing that I have to check. So all high equals, if it remembers, high pulses for all inputs. Conj state in dest equals high. Now, we have to do something like this, except this is a little bit verbose with too many curly braces. Okay, so when does it do a low pulse? If it remembers high pulses for all inputs, then it sends a low pulse. Otherwise, it sends a high pulse. Okay, so I think this much is correct now. And then I have to just relay that pulse to the destinations. Again, I don't really need a curly brace there. Pulse out, I think that's it. Maybe I could have this outside of the conditional, but like there's also, yeah, I don't know. There's this other weird example where like you have some other thing that has no outputs or inputs, but it's not a broadcaster. So I'd rather not test that input if I don't have to. Okay, so I think that did more than it did last time, and that's good. So we did this many pulses. We ended at 2, 4, 3. And then we have some more stuff. Hey, BetSimp, welcome to the stream. Yeah, this is part 1. I've been at it for, what, 2 hours and 6 minutes now? And I just finally did my first button press, I think. So I had this much before. I was processing the broadcast pulses, and I was processing the flip-flop pulses. But then I just finished implementing the conjunctors, whatever they're called. So I think I have to check if that stuff is right. So A high to B, that's 2, 2, 1. A high to, or B high to C, that's 2, 3, 2. And then C high to inv is 2, 4, 3. And then we process the inverter. So inverter sends low to A. Low is 1. So we have basically 4 lows. It's 4 ones. And then we have a high signal. So I think the pulse types look correct. I'm not checking the sources and destinations because I don't remember which indices those correspond to. I'm just going to assume those are correct because I did at least get the pulse types correct. So now I think I have to like iterate through this 1,000 times and then just count every pulse type. Without adding a loop for 1,000 times, I should be able to count 8 pulses, or 8 low pulses and 4 high pulses. I should be able to count those. And I think we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 ones in like the first element of the Q data vector. And then we have 1, 2, 3, 4 high pulses. So 8 and 4. I think that's correct. I'd rather add those up programmatically instead of just counting them manually. So let's see if I can do that. And I think I can just count them when I pop them off the queue. So immediately after I pop them off the queue, I can just count them. And then I don't have to have like separate logic that counts things when I'm pushing them onto a flip-flop versus a conj versus a broadcaster. I can just centralize this right under the popping. That should be it. And then these should be 8 low pulses and 4 high pulses, I think. Okay, 8 and 4. Did I have those in the right order? 8 low pulses and 4 high. Yeah, that's correct. This is a bad example because the same thing happens every time I press the button. But I'm pretty confident that I have the states set up correctly and they should be remembered every time this happens. I can delete some of these curly braces. They're not all necessary. Okay. I want to make sure I didn't break anything right there. Okay, it's still 8 and 4. Now let's try this 1,000 times. Is it always? It's always 1,000 times. And then we wait for all pulses to be fully handled after each push of the button. So I'm not gonna put a loop around this. Come on. I'm not gonna put a loop just around this. I want to push and then do all of the handling inside the loop, inside this outer loop. I don't know if I'm even gonna bother indenting that just yet. Zero through 1,000. That should do it 1,000 times, not 1,001 times. So now we should get 8,000 and 4,000. It's gonna take a second. Only 2 seconds. 8,000 and 4,000. I probably want to turn off some of the logging. I don't know. What's the final answer? Like we multiply one of those numbers by the other? So multiplying these together gives 32 million. Do I need 64-bit integers? I don't know. Not for the test input, at least. So it should be 32 million or something. Okay. I bet for part 2 they're going to make us press the button like 1 trillion times or something stupid, and I really don't feel like doing that again because we've already done that twice this year. But I think I'm ready to try this on the real input. And I'll probably just end the stream. I'm not... God, it crashed. I'm not ready to do part 2. Oh, I'm not even parsing the... I'm not even parsing. That's not good. Is there something here that doesn't have any outputs? What happened? Outputs is empty. That doesn't seem right. So it's CN after JL, HV, XS, MQ. Then we have CN. And then it just crashes. Am I like exceeding a buffer or something? I did not expect any difficulties here. I thought I had the parsing part finished. So it's not crashing in that loop because I printed all this stuff. And then I think it's crashing somewhere in here. So we got to line... Yeah, that's where I thought it was crashing. 53. is nmod? How many modules did I detect? That's going to be all the way at the beginning. 58. So I'm not going out of bounds on that. The only capacity I have is the queue capacity. That might need to be bigger, but that shouldn't cause it to crash while it's parsing the input. Okay, no, it must be crashing here. So CN? Is CN like not an input anywhere or something? It is. Is it ampersand CN? Yeah. You have to move the chat. Sorry if I miss any chats. So I have CN. CN is a valid label. But why is outputs empty? I feel like I have some kind of terrible memory bug. Can it not print this? It can't print this for some reason. So I have like type corruption or something. Because why would it not be able to print this? What if I just don't print it? Still crashes. But I get one line further before it crashes. I get to 54 instead of 53. Something is extremely cursed in here. if I rename one of these variables, else, and then I don't have like shadowed variables with the same name in different scopes. Still crashes. What is going on? What is the split function doing? I've looked at this a lot before, and I thought this was very well tested. And I got paranoid one time before, and I thought that split wasn't working, so I debugged this very carefully, but the bug turned out to be somewhere else. But now I'm suspecting it again. Hey, Kelly. I know, it's late. Is this overflowing? No, because it says a string index is overflowed. J. Oh, yeah. Yeah, it's trying to look this up. Oh my god, Rx is only an output and it's never an input. Why do you gotta do that, man? Will this... I have a feeling that this is going to break something. This is so annoying. I just want to be done with this. I'm not even asking to solve part 2. I just want to be done with part 1. So obviously I need the same bounds check guarding this expression. And then I think that should fix everything else. So if I say that this is not an input, everything else should be fine. If elt ji less than nmod, then we do that. Otherwise we don't really increment anything. And it still crashes. Where is it crashing now? Oh, because it's still... because it checks this condition before it checks this, so this still overflows. How do I do this without overflowing? I'm too tired. I think I'm close though. If I can parse this input, like the test input was working fine. It's just this pathological case where you have an output that has no that doesn't exist in the table. So like Rx, it is like that. So like in the other one, they actually named it output, and then like I searched for that, and I was like, well, there's nothing named output. But now we do have an untyped output, which does not exist as an input for anything else. So I was like, I don't need to handle this case. It doesn't exist in the real input, but it does. I just didn't know how to look for that string. Shouldn't this fix it though? No, because we increment by 1 and then we check this again. I mean, that's not right, because then I'm just not going to look up anything that's the last input. I know this isn't right, and it crashes somewhere else anyway. This is so annoying. And it still crashes. And it's still crashing in the same place. I'm tired. I need like a local variable so I don't have to repeat these indices all the time. 57. So 57 should be a valid index. Now where is it crashing? It's some integer array index. Well, yeah, it's that. But I have this check here. If it's, I only increment this if it's less than. Oh, okay, so I also have to do this inside. I'm too tired to catch this in a reasonable amount of time. That should not have taken so long. Something is still crashing. So now, like every time we process a pulse, does this still count as something that I should add up, or doesn't it? Now I have to have like bounds check guards everywhere, because this is like an invalid module that doesn't exist. So elt is... Where is it? It should be like 3 from the end. Okay, yeah, so we have 58, which is actually the number of modules, so that's out of bounds. So anytime I see a 58, I should basically ignore it. This is so annoying. Now, I think it's right here actually. No, it's gonna be so DST. Now DST could be invalid because this got pushed and then it got popped. So now this is the thing that potentially needs a guard. I think if I do it like that, I can pretend that I don't need any more indentation. It's going. Yeah, it's still crashed. Maybe... Oh, I think my queue is overflowing now, and I have no guard on that. So when I push, I should really have a guard. How did I do this yesterday, or whenever the last time I used a queue was? I don't think it was... It was day 17. I used a queue in day 17. So when I push at the beginning of this, I check. So I think this is actually a queue cap overflow. Yeah, alright, I know how to fix that, that's easy. Let's just make that a lot bigger. No idea how long this is going to take to run. Okay, we got a number. And I don't think integer overflow should be a problem. I think I'm so done after this. Even if it's wrong, I'm not going to do anything else. Yeah. If that was wrong, I would have just rage quit. Yeah, I noticed RX. That just sent me into like a 20-minute debugging cycle. I don't know, that doesn't sound that hard. I think I will attempt this on stream. Unless it takes like a trillion. It shouldn't take a trillion, because if on the days where they ask you to do like a billion or a trillion or some crazy number of things, there's a cycle. And you can detect a cycle and then extrapolate. But if there's a cycle that will eventually get us to RX, you would still have to have that happen within the computable range of things. So I don't think we have to do any crazy stuff like that. And I already know about RX, so I just have to look up RX by its index and then keep iterating until it gets a pulse. But I do need a break. I need to grab a snack and do some other stuff, and then I will be right back. All right, we're back. I got some PB Cliff, a little bit of peanut butter Cliff Bar. I can always go for some. Okay, I think I'm unmuted now. Got some PB Cliff, a little bit of peanut butter Cliff Bar. I very carefully muted myself and then not so smoothly tried to unmute when I got back. But did you guys hear about Vivek Ramaswamy taking a piss on Twitter Live without muting himself? I hope I didn't just do that. I think I did that a little bit better. I have so many global variables and states that I'm worried that I might not have reset the state correctly. So I'm just going to comment out part 1 and only do part 2 for now. And then at some later point, I'll try to make sure that they can both run and give me correct answers. But I don't want to have like any state leakage between part 1 and part 2. Okay, so we want the number of button presses. We don't care about the number of pulses, and we don't have to break like mid-button press before the pulses have finished processing. That's good, that makes my life easier. I can just do like a whole button press loop, and I don't have to break that in the middle of it. That didn't work. What the hell did I... Oh. I know. Yeah. I can't actually look this up. I just encoded it as being out of the index range. So I don't want to look this up because it doesn't exist on the input. That's all. I expected it to run longer than 7,000 cycles or whatever. Oh, come on, man. I think... Oh, I just didn't print the right answer. I'm still printing n low times n high. Yeah, 9 times 30. Yeah, I'm still printing n low times n high. 9 times 35. I just printed the wrong thing. And what I want to know is the number of button presses. Now this might be off by one. I don't know. Do I care whether it's high or low? Oh, it has to be a low pulse. Okay. Eric just wants to make my life complicated. Come on, man. That goes a little bit longer. Or it crashes. Easy. I just increased my hard-coded upper limit. I have a queue for holding my pulse information, like whether it's low or high, what the source is, and what the destination is. And that's just a fixed size array. And if it overflows, I don't have anything to like reallocate it. I could. It should be possible for me to add dynamic copying to like a new, bigger array. But if I can just change one number and rerun it, why not? Welcome to the stream, Communicore. Communicore. I think I'm pronouncing that close to correct. $300 trillion. Okay. I have to come up with some way of optimizing this because this is not going to work if it's around 300 trillion. Yeah, I have no idea how to do this. Callie, you're not supposed to be on the desk. Yeah. And it still overflowed the cap, or the queue capacity. Yeah. I have no idea how to analyze this to figure out how does the state change with one button press. There has to be some sort of like meta-analysis you can do rather than just interpreting these pulse signals directly. Callie, that's my microphone. Yeah, I think I'm going to have to call it a night and end this stream because I'm going to have to think about this for a while if I have to do 300 trillion button presses. Callie, I need to commit to GitHub, Callie. Okay, I'm going to commit what I have. Are you just watching RX? Yeah, so I have, well, RX is special because it exists as an output, but it doesn't exist as an input. So I have this special logic. What line number am I on? So basically I look up every output in the list of module names. So that should give me something in the range of 0 to the number of modules minus 1. And now I'm encoding RX as being something that doesn't exist, which I just set it equal to nmod. So that's like 1 past the end of the array. So I'm watching RX by seeing if I ever pop a pulse out of my queue, I get a pulse type and a destination and a source. So if the destination is ever one past the end of that array and the pulse type is low, then I say, okay, something finally hit RX. I know that RX gets a high pulse on the first button press, but apparently it takes a very long time to get a low pulse to RX. So yeah, I don't know how to do this other than just watching RX or like doing some meta-analysis to find a pattern to the way that the states change with one button press. Yeah, I think I'm just gonna have to commit my code as is and maybe think about this for a while, or maybe just give up on day 20. Let me verify that that pushed. Like, I don't know how to do this other than watching RX. I can watch RX or I can watch CN, and like yesterday the trick was to work backwards, to know that like you end at the acceptance endpoint and then to figure out what ranges you had to be in to get there to satisfy the conditions, and then work backwards and figure out which line calls that function. But like I don't even know how to work backwards from this. So I know, well, if I'm watching RX, then I need to watch CN, and if I watch CN, then I don't know, is working backwards something that you can do like yesterday? At the very least, I will have to think about this for a while. I'm not going to figure it out right now. But yeah, here's our code for part 1. And we made an attempt at part 2, but I have no idea how to simulate 300 trillion button presses. Alright, that's it for now, and I will catch you next time.